And we've got some activity setting on the western limb of the sun. A new sunspot forms in the southeast. That and tons more. Brought to you by the Smash News Network, least busted name in news. Let's get to some space weather. Here's 304 angstroms, and don't be surprised to see additional coronal mass ejections. There's actually some ejecta coming out of the sun at the moment. We may have to make another video later in the day to cover that. First, the magnetic fields. It's your colorized magnetogram from the SDO, the Solar Dynamics Observatory. So we do have some magnetic organization happening up here. And also a new sunspot group down here. It's already a beta gamma class sunspot group. So it's growing quickly. Here's another full disk image. It's 335 angstroms. Radio flux all the way down to 84. So the 10.7 is the most proportional data set we have to sunspot number. Keep in mind, folks, the AP index isn't really that low at the moment. But yeah, sunspot number now going to come back up a little bit here. Again, radio flux only at 84. No space weather storms forecasted here. Let me press refresh. So no space weather forecasts for geomagnetic unrest or storms or anything like that. I do expect some glancing blows from a few coronal mass ejections arriving in a day or two. They're minor glancing blows, though. Largest earthquake of the past 24 was this 6.0 at the Mid-Atlantic Ridge. There's a location of that right in the middle of the Atlantic Ocean. Not a lot around. Let's scroll up the list from the past 24. Deep quake at Fiji, deep quake at Argentina. Japan had a 5.8. Actually well south of Japan there in the western Pacific. Taiwan had a 5.0. That was actually a 6.1 at the Mid-Atlantic Ridge. And what is this one? A 5.0 at Tonga at 265 kilometers estimated depth. And next we'll look at volcanoes. Let us know if you felt any of these U.S. quakes. Let us know if you felt a quake, period, in the past 24. Here is the volcano rundown. Suwano-Sejima producing an 8,000-foot ash plume as it explodes. That volcano located in the Ryukyu Islands. Luitolo in the Lesser Sunda Islands also erupting, 7,000-foot ash plume. Flight level 140 from Semeru, one of the more active volcanoes of the past couple of weeks. Semeru located on the Isle of East Java, Indonesia. Flight level 140, 14,000-foot plume of ash. Fuego exploding, 15,000-foot ash plume over Guatemala, Nevado del Ruiz. Located in Colombia. 20,000-foot plume of volcanic ash from Nevado del Ruiz. Sangay and Revenador are still at it in Ecuador. Flight level 210 and 150, respectively. 21,000-foot ash plume from Sangay. 15,000-foot ash plume from Revenador, and Sabancaya also erupting in an explosive fashion. 23,000-foot ash plume of flight level 230 over Peru. Please don't pole vault the caldera. Please do make America not suck again. It is up to you and me and individual humans to make Earth not suck again. One of the ways we make Earth not suck again is by making America not suck again. Congratulations to everybody who's been doing so. We greatly appreciate your attention to non-suckage so far throughout the year 2022. Let us know in the comments if you think things will be improving or getting worse in 2022. Lots of polls seemed to agree that 2021 sucked even harder than 2020. So make America not suck again. It's up to you. SMASHOMASH.org is doing our part. So please help us out. Pick up some merch and tell your friends and foes about us. Or support the channel by becoming a member of the Smash team. You can find links to that at the homepage, SMASHOMASH.com. The merch link is right there, as well as below this video. Thanks to our gold and silver and gold annual paid-up subscriptions at SMASHOMASH.com/SmashTeam. Giving out some information nobody else gets to see. There's a teaser. Again, links on the homepage to that. It's magnetic, like this data from the GOES 16 and 17. And we see a waning of plasma from the coronal hole wind stream, a slowing down of the solar wind speed. And Earth is still in a South Pole current sheet. There you can see the two polarities, heliospheric current sheets here. This one's the North Polar current sheet. North Polar current sheet, South Polar current sheet. Here's the line of sight view. Yeah, the plasma is oriented to one of the poles, folks. Also, there's a solar polar field reversal going on. It's called a solar cycle. Some coronal holes here rotating in. They're South Pole oriented. North Pole ones sort of making their way to the western limb. Here's this South Pole oriented coronal hole just ahead of this new sunspot group. So likelihood of flares goes up a little bit with that sunspot group. We'll be off of a sunspot number of 0 back to a sunspot number of some. I'm not going to try to do the calculation, but there we go. There's a new group. It is now beta class, so look for this to be updated soon. It's pretty small. The likelihood of flaring has increased. No major flares over the past 3 days. No proton spikes either. No relativistic particles showing up at Earth from things like solar flares. Solar wind has diminished over the past 24. Now down to about 438 kilometers per second. Density only 5.17, so returning back to very low solar wind speed and density here. And not a lot on the way, just a couple coronal mass ejections, and there should be a signal. There should be a signal in that we're seeing back to like nominal levels here. Next KP index at 2. Global geomagnetism in a calm state. Here's the last 4 hours of geospace. Earth magnetic moment from space in nanopascals. Magnetohydrodynamic pressure. Things should be fairly homogeneous here over the past 4 hours. No big changes to the solar wind, so no big changes there. Also a little bit more organized electron flux. We'll get to that in a moment. First, ground magnetic perturbations. And likelihood of aurora not so high at the moment. With the subsiding of that coronal hole wind stream, we're back to sort of background solar wind levels. Again, a couple coronal mass ejections headed Earth's way. They're both minor. They're diffuse and probably not super high speed. Next, a forecast for the solar system. And we've got a crescent waxing. Let's see where things will be in a week. We'll be at a gibbous waxing by the 11th. 1/11/22, some sort of a math day, I guess. And check out the astronomy picture of the day today. It's normally in our cosmology segment. The rings of Saturn and a couple of Saturnian moons, Rhea and Janus. Great imagery there from the Cassini back in 2010. apod.nasa.gov if you want to check it out yourself. Here's a star chart. If you're up before dawn, you might see Mars rising ahead of the sun. It's now light out here in Lehigh Valley, Pennsylvania. Let's move on and blast through more data. There have been additional coronal mass ejections since yesterday's video. That's why we haven't suspended the coronal mass ejection warning. Did we reduce it to a watch? I think we reduced it to a watch, but there is an additional coronal mass ejection. So early today we saw more ejecta. Some of it's on the far side of the sun and some of it is still propagating now. So we'll be keeping an eye on this, and when I say ion, who will pardon the pun. So I would say some of the ejecta from this event here likely to strike the Earth magnetosphere. Some of it is on the far side also, as you can see this area up here. So additional coronal mass ejections, we're going to be at 3 headed Earth's way once this is done propagating, probably. Today's cosmology segment's integrated to the daily space weather video. And we regularly talk about cosmology because heliophysics is tied into cosmology, folks. The important thing to understand about the reason that it's so important to understand the sun is that the sun is the basis for which all cosmology exists. Basically, the standard concordance model of stellar evolution is what bases what everybody thinks is going on when it comes to distant galaxies and so on. We're going to pick a quote random and quote number. Today's is a very interesting one. It's a low-mass X-ray binary located on the outskirts of the Large Magellanic Cloud. These are the X-ray emissions from it, LMC-X2, an X-ray source adjacent to the Large Magellanic Cloud, but not really in it. And you can see there was a bit of a spike in activity here just yesterday. Otherwise, it's a pretty consistent source. That's the 30-day chart there down in the lower left of its hard X-ray output. Yes, I said hard. So it's only bright in small portions of the electromagnetic spectrum. Those are the photometric points. And let's take a look at it visually here at the CDS portal. So here it is on the DSS-2, the colored imagery, and we're going to zoom way out so you can see the Large Magellanic Cloud. There it is. It's a satellite galaxy of the Milky Way. If you zoom way out, you can see the Milky Way disk there. And we'll zoom back in to LMC-X2, where it is dark, mostly in visible spectra. Let's check X-rays. So here's some X-ray imagery from the exostat. You can see a large X-ray source there above the crosshairs. Here is the XMM Newton, a little bit more commonly used survey. And you can see it's a very, very bright X-ray source. LMC-X2. See if it shows up on the Chandra. And it does not, but here is an all-sky survey. You can see how bright this is compared to other X-ray sources. One of the brightest in the entire Large Magellanic Cloud. I think it's the second brightest, hence the name, LMC-X2. Does it show up in ultraviolet? I would suspect it probably does. Here's the Galix color composition. Let's see what we see. Not a lot of features there. Perhaps like a microgalaxy inside a galaxy is going on there. And let's zoom into this area with the XMM Newton Ultraviolet Survey. Some interesting features there. A nebulous cloud of ultraviolet emissions here in various different wavelengths. You can see that sort of adjacent to X2. Perhaps it's a thing like a pulsar going on, but in any case, it's a low-mass X-ray binary. What do we see in optical? On the Sky Mapper survey, let's check this one out. And some optically bright objects there, but not at the location of our crosshair. Let's see what it looks like in infrared, and it's looking pretty cold in that part of space. Again, this one only lit up in certain spectra, certain portions of the electromagnetic spectrum. Pretty cold in that location, but a very bright X-ray source. That's today's quote random and quote object, Large Magellanic Cloud X2. Entry number 170 at the Neil Gehrels Swift Observatory Transients page. Let's talk about cosmic rays. Cosmic rays are kind of important to what's going on planet Earth, so we cover it on the regs. Cosmology. It might be weirder than you think. Cosmic rays are high-speed atomic nuclei, mainly hydrogen, but also all of the heavy elements. Basically, all of the elements on the periodic chart have a tendency to sometimes blast through space at relativistic speeds. They're being measured here on Earth at Apatity and Barentsburg. So here's the 30-day chart at Apatity, and we see an uptick actually in the past 30 days at Apatity. Flat at Barentsburg. Let's go someplace farther south. Keep in mind these are pressure-corrected data, if you're wondering. The Athens Neutron Monitor, pretty flat here over the past 30 days. Even farther south to Mexico City, also flat over the past 30 days. And let's take a look at Oulu, Finland. There's Oulu. Flat over the past 30 days. Let's get DOMB Antarctica fixed, people. It's summer in Antarctica. And I think there should be a bunch of people working down there. Hopefully they're not locked down and quarantined despite having no symptoms. Or worse yet, hopefully they're not having symptoms. Next, DOMC Antarctica, which does show data, and it's showing an uptick here over the past 30 days at DOMC as well. So interesting cosmic ray report there. Some upticks in cosmic ray flux, minor ones. Anyway, that's today's cosmology segment. Again, it's integrated in the daily space weather video. Don't forget to check our playlists for over 200 cosmology segments. Let's get back to the regularly scheduled space weather. Next, looking at charging hazards for satellites, we don't see any at the moment. We see fairly organized electron flux here, just at nominal levels. That's a 1-year chart to put it in context. Here's a 3-day chart. Just nominal levels here of electron flux measured by the GOES 16 and 17. There's the forecast model. No arguments from me on the NOAA forecast model there for electron flux. The green boxes are the forecast. The yellow diamonds are the observation. Next, the total electron content. And this is returning back to a more normal, organized pattern here, which we typically see when we see higher levels of electron flux. So we'll let that play through there. This is showing you literally the count of electrons and the most likely spots for GPS errors. Looking a lot less anomalously than it has the past couple of weeks. Next, we'll show you the ionosphere layer. We see some significant anomalies around the southern hemisphere. Here's the F layer in vibrational frequency. And we've got low-frequency anomalies around South Africa and the southern portion of South America, the Drake Passage. It'll be more evident in the anomalygram if you're not familiar with looking at our ionograms. We show them daily on the daily space weather. Anyway, we'll let this play through. We'll bring up the latest image. A couple high-frequency anomalies looking like they're happening in the southern hemisphere. But here's the anomalygram. This is anomaly in megahertz from the 30-day median. You can see low-frequency anomalies, especially in the southern Atlantic, South America, South Africa, and indeed Antarctica. So sort of consistent low-frequency anomalies there. And widespread ones. Perhaps giving us some insight into Earth's inner workings, right? Anyway, there's the latest image, 12:45 Universal Time on the ionogram. There's the anomalygram, and how about some bonus features? First bonus feature is the ground-based solar observatory at El Teide, Spain. I would note a bunch of filaments in the southern hemisphere. Some of these are on their way out. In fact, you can actually see one looking like it's vanishing here. That's because it's ejected. And most of it is headed to the south of Earth. Some portion of it likely headed toward Earth. It'll cause only a minor blip on the solar wind. If you want to watch more CMEs unfold, the GOES 16 SUVI is a good choice. It's got a very wide field of view, and it's great at showing prominences and filaments in 304 angstroms. It'll refresh. You can use it as your desktop all day if you like. That's why we stream it live to Twitch on the regs. Next, the latest colorized magnetogram and intensitygram. And this new sunspot is beta class. I see at least some additional trailing umbra there. certainly a beta-class sunspot. This one up here might now be a sunspot as well. Let's take a look. I think I see a number forming, so it looks like we've got 2 sunspot groups likely to form here. We'll close out today's space weather with the northern hemisphere as some activity sets in the northwest. Some rises in the east, especially this sunspot. That'll be the latest named group for sure. Anyway, we're out. Visit the links, support the channel, since YouTube largely doesn't, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted. Name it news.